Let's find the equation of a line that is parallel to this line here. Parallel means same slope, so the slope is 3, and goes through this point here. We have a slope, and we have a point. Let's use slope point form. Y minus y1 equals mx minus x1. So let's substitute. Y minus 2 is equals to the slope x minus 3. And so this here is technically an equation. If you really want to have slope point form, you can use distribution. Y equals 3x minus 9. The negative 2 thrown over becomes a plus 2. Negative 9 plus 2 is negative 7. So we also have this form here. Now we have a different question. The y-intercept is 4, which implies the point 0, 4. And we have the slope that is still the same. And previously we found the slope is 3. This question is connected to the previous. And so again, we can simply say y equals mx plus b. The slope is already given as 3, and the y-intercept is simply 4. Now what if we have a slope of 3, and the x-intercept is 6, which means that the point is 6, 0. The opposite of x, which is y, is 0. So let's try using slope point form. Y minus y1 is equals to the slope x minus x1. We'll just use distribution here. Y equals 3x minus 18 would be our new line equation. And now we're finding an equation of a line that is perpendicular to this line here. So perpendicular slopes are not the same, they're the negative reciprocal. So we'll say that the perpendicular slope is not 2 over 1, it's negative 1/2. And we have a point, so let's use slope point form. Y minus y1 equals mx minus x1. Y minus 1 is equals to the new slope, x minus 4. So this here is an acceptable answer, and if you really want to expand it out, you could. Y equals negative 1/2 x. Negative times negative is positive. 4 over 2 is 2. When we throw the negative 1 over, we have a plus 1. So 2 plus 1 is 3. So we have a slope and we have a y-intercept. Now, what if we had this nice new slope, the perpendicular slope, and also the point 0, 0, the origin? Again, we use the slope point form. Y minus 0 equals the new slope, x minus 0. And so thus, y equals negative 1/2 x is the line equation that goes to the origin. And now we have an application of lines. We're going to draw a line through these 2 points. And we can see that the line keeps on extending, and eventually we're going to hit the x-axis. But this is not simply a y-x graph. We're talking about the volume of gas, and we're talking about t instead of x, time. When do you run out of gas? In other words, when is the volume equals to 0? Now, unfortunately, we can't really guess too accurately, so we need to come up with a line equation. Now we are given 2 very accurate points here. And the points are, this is time equals 1, time equals 2. 2, 10 is 1 point. And this looks like it's 4. 4, 5, 6, 7, 8, 9. So we'll say that 4, 9 is the other point. So we have 2 exact points. Let's find the slope, or the rate of change of volume with respect to time. Slope is rise over run. So why don't we go 9 minus 10 over 4 minus 2. So we have negative 1 over 2 is your slope or rate of change. Negative means we're losing some gasoline as time passes by. So now let's find the equation. Let's just use any point. We'll just use this point here. We'll say y minus y1 is equals to the slope x minus x1. And of course we can use v or we can use t's instead of the x's. But let's just finish this off here. Y minus 10 is equals to the slope x minus 2. We'll use distribution. Negative times negative is positive. 2 divided by 2 is 1. And we'll add 10. So 1 plus 10 is 11. So we have a volume formula. The volume as a function of time is equals to negative 1/2 t plus 11. And so the question is, when is the volume 0? So 0 is equals to negative 1/2 t plus 11. We'll throw this over here, making it positive. 1/2 t is equals to 11. And finally, multiply both sides by 2. So at 22 hours later, we run out of gas.